Good afternoon, everybody, and welcome to the latest East Anglia IRSM branch presentation. Today's one is What the Hell? Now, what I'm going to do is hand over to Phil, that's it, Director of Logic Safety Solutions, who will quite happily introduce and explain what the hell is all about. Over to you there, Phil.
Thank you. Good afternoon, everyone, and well done, Rob, for not saying "what the hell" as I played with the L phrase a little bit. We've got quite a lot to cover today. I just want to kind of give you an overview of what the subject is, a little bit about me, and the way the webinar is going to work for today. Um, this presentation will cover the risks, fire impact, the use and consideration of extinguishers, with reference to lithium batteries, lithium ion batteries specifically. We will touch a little bit on lithium metals. And before we do that, I'll just give you a quick overview about myself. If anyone has obviously any questions during the webinar, by all means, I'll put those into the Q&A. We'll answer those at the end. And anything that we can't answer, we'll come back and have a look at that following the webinar and get back to people individually. As Rob mentioned, I'm Director of Logic Safety Solutions. Prior to this, I used to work in the leisure sector. Not really much use of batteries in those sectors, but both in a local and national role. Found myself doing more health and safety related regional aspects, and from kind of 2006 to 2017, worked with a number of large management consultancies and did everything from high risk, fire risk assessment through to construction site management and pretty much everything in between. And now I find myself routinely in the middle of a festival with 60,000 people and dealing with power solutions and so forth. Hopefully I'll be able to answer questions that do come out of today. And as I said, anything we can't answer, we don't have time to, we will follow that up. So the agenda for today is to look at the emerging developments with regards to extinguishers and fire blankets, particularly around the lithium-based fires. We're going to have a look at the risk, the fire impact, and look at the extinguishers and blankets. We're also going to have a look at a little bit of statistics and some of the kind of the changing kind of demands that are put on workplaces to use this new technology. And as technology kind of progresses, how it will potentially have a greater impact. At no point today are we looking to give you answers of what you should or shouldn't be doing. There is a risk-based approach. You should work with your fire risk assessors and try to, in some way, attempt to understand what that risk looks like. Each business is obviously unique, so having that competent fire risk assessor supporting you is really important. So, look, we know that lithium batteries power many workplace devices. We've got a good understanding of the risk, and we've seen lots of articles in the news regarding fires, both locally and over in national press. And most manufacturers are providing really high quality equipment, but even these items can fail. And we've seen, as you can see in that picture there, if you remember back in 2016, we had the phone recall from Samsung regarding their Galaxy 7 Note, and there was a battery defect, and that battery defect led to the phone overheating, catching fire, and Samsung did a international recall. That obviously had quite a costly expense. The company then issued replacements, but during that phase, there was a lot of guidance provided, such as the phones not being used on aeroplanes. And ultimately, for the company, they had to halt production before coming out with a new edition. So I suppose that was the first kind of big bit of news that we saw 10 years ago. And since then, there has been a lot more information provided by local fire authorities and also international bodies with regards to the use of battery lithium powered devices. So having seen an increase in the availability of these increase in these risks, we've also seen a reaction from the fire sector, particularly the manufacturers of fire extinguishers and fire blankets. And certainly, one of the things of bringing this presentation to everyone today is that I found there has been questions about what do you think to lithium extinguishers? What do you think of various types of fire blankets? And I suppose what I've done is I've gone away and tried to have a pragmatic approach. So we can have a discussion here today on the webinar, but also those discussions I can have with clients that provide an opportunity to guide them in the right direction. So hopefully today will do that. So I'm in no way a specialist regarding lithium metal or lithium ion batteries and the risks that they face. You would need to speak to the manufacturers of the equipment that you purchase and how you use it. It's for them to give you information about some of the tolerances or intolerances that equipment might have for various use. Other than that, if it's not a manufacturer piece of guide, it has to come from kind of industry as a whole. And when we talk about lithium batteries, we know that they are a high energy rechargeable battery that is used in lots of everyday objects, such as laptops, mobile phones, power tools, even forklifts, e-bikes, drones. We've even got medical devices and more. The list is kind of endless. And there's been a big step away, particularly in some industries like construction, away from using 110-volt tools on site to all of a sudden using lots of battery powered tools, which whilst it controls one risk, it introduces others. So the technology that we have offers high power, density, long life, and quick charging. Um, these benefits do come with risk, and we've seen action being taken by lots of different sectors, including airlines. Airlines are now looking at battery power banks that we have for charging some of these devices whilst flying, and they've started to look at really putting guidance and controls in place to say, look, between 100 and 160 watt hours, those devices, they might be able to be brought onto a plane, but you might not be able to use them. You might be able to use them, but they might be restricted. And some now are actually saying they need to go into the hold of the plane. They can't come onto into the passenger areas. And I suppose when I asked, when this question is asked in the specific sector of aviation, there is a question for us. What is your workplace regarding the use of personal electrical equipment? But also, what are your policies and risk assessments with regards to what the purchase and procurement process is around this equipment? Early last week, I saw a post from a an engineer that works partly in the construction sector, and he bought some cheap power tools. And I suppose I question whether those cheaper tools are necessarily robust in their safety and their quality. And whilst we look for CE markings in UKCA or UKNI following Brexit, it's really important that the procurement process is considered. So we've got an understanding of where these lithium batteries are being used. You've only got to look around your office, your workplace, your home, and you can see the kind of evidence of them creeping more and more into our lives. So they are something here to stay. But when we talk about lithium batteries and we see the evidence from, or the consequences, should we say, following the fires, there's often wording around thermal runaway risk and what thermal runaway is. So when we talk about battery fires, this phrase thermal runaway is essentially a chain reaction. Thermal runaway is a dangerous chain reaction. There's a self-sustaining or self-accelerating process where a cell, the internal temperature starts to increase due to what we refer to often as a positive feedback loop. And as that heat starts to generate, we have an increase in temperature rate rise. We then have thermal propagation, and this has a cascading effect through the rest of the battery cells. And this is where the runaway heat spreads from one cell to another. A bit as we can see with the image, it starts in that one cell in that battery, and it'll quickly spread from cell to cell, and that kind of chain reaction. And as the cells generate more heat, that can be it can't dissipate that heat quickly. That heat is then transferred, and it often leads to potential catastrophic events. It's not just a fire, it's not just that initial smoke, but we have to recognise that depending on the design and the temperature rate rise, it can have more of an explosion type of effect. So going through a risk assessment based approach, we need to understand the hazards with the battery powered equipment, such as overcharging. There can be physical damage, particularly with items that are dropped. There could be crushing and puncturing into the battery cells. Even batteries that aren't on charge, if they're exposed to heat sources, direct or indirect, that can cause failure in the cell itself. There's also the manufacturer defects that we've talked already with Samsung that they've had, but also we see a lot of defects coming through on items such as scooters and bikes, and just general internal short circuits. So the thermal runaway risk is ever present. It's always there. It's hard to manage unless we start to understand what other aspects of the way the tool or piece of equipment is being used, how it's stored, how it's transported, and also making sure we don't do simple things like charge phones up overnight and leave them in your bed, under your pillow, those sorts of things. So these are the components that might increase and lead to that initial trigger, resulting in that exothermic reaction. So thinking about the fire and explosion risk, we know that lithium battery fires can and do burn far hotter than conventional fires. Where we have a lithium fire, these often reach temperatures of around 1,000 degrees C. And at that temperature, obviously, we've got life-threatening conditions, particularly within enclosed environments, that can occur extremely quickly. We're also at a point that as that temperature increases, other items in the room might get to a point where we get spontaneous ignition because they're hitting that kind of often 500 degrees and above. That those temperatures will lead to more drastic effects of combustion within the rest of the workplace or the home, depending where they're being used. Now, the difficulty with batteries is that they can ignite and unexpectedly explode when you don't recognise it's happening. There's this pressure build-up, and unless the battery is fitted with a battery management system to prevent overcharging, the battery will get to the point where that pressure increases, and we have this fire and explosion risk. The battery management system within the device prevents this overcharging. And what it does is it monitors the individual cell voltage, and also has a mechanism for cutting off the charging process once the cell meets its maximum safe voltage. It also helps to regulate both that charging process and discharge when the current's being pulled, when the power's been pulled away. And that essentially helps to manage the battery temperature. The advantage of that is also it helps to manage the lifespan of the battery as well, so these batteries last longer. So whilst we're aware of this fire and explosion risk, again, if we buy good power tools and equipment, there is this battery management system that should, in theory, manage and regulate how the battery is being charged and how it's being used with any devices that you might have. Within the wider scope of risk, the dangers are with a fire involving a lithium ion battery is linked to the toxic gas release. And any batteries that fail will always release toxic gases. These can be released quite rapidly, and we are going to see a short video with a scooter fire in which the room where the scooter catches fire releases a vast amount of smoke before the fire is actually realised. So during failure of the batteries, the release of these toxic gases, such as hydrogen, carbon monoxide, hydrofluoric acid, will result in the harmful effects of to the individual, whether it's contact with the eyes, which can cause burns and might not immediately be painful, but depends on the concentrations, but there might be a delayed effect. Obviously, we can have inhalation, and inhalation can again lead to irritation around the eyes, nose, and throat. But also, it can lead to pulmonary edema, which is a fluid buildup within the lungs. If there's any of the toxins that get into the digestive system, that will affect the digestive tract and maybe cause more longer term ill health effects. So when we think about the kind of the process of today, and we're looking at the emergence of different types of firefighting equipment, it's also important that we think about the risk that our staff might be exposed to in the event of an incident. We've got to think about how we protect those individuals. And if you've got trained fire marshals, those that have been on that fire awareness training all the way through to hands-on, having a go at putting the fire out, we've got to consider the dangerous volumes of vapours, smoke that are released that could cause long-term ill health effects to the individual, because they are highly flammable in those gases. They are toxic when inhaled, and they are produced often in large quantities, even when the battery can be fairly small and fairly minimal. The effect itself can be far greater in reality than what you originally perceive it to be. So we've touched on this risk around the charging and the stresses that are put on the cells. Overcharging, or consideration for maybe using an unofficial or a third-party manufacturer charger, can increase the stress that's put on the lithium-ion battery, which might lead to a serious safety hazard. So when a manufacturer provides a charging device, it's important that you use that approved charging device and you don't look to select a cheaper alternative, or an alternative that isn't compatible. So you must always read those manufacturers' guidance, because the electrical stress, as we talked about earlier, will lead to that primary risk of thermal runaway, that self-sustaining kind of spread of the fire, and it might just be as a failing in the equipment's battery management system to recognise that the battery that's being charged is now full. It's now fully charged, and depending on the indication, the warning system that's involved, it might not turn itself off. So good tools and good equipment will do that automatically. Now we can have things like cell damage and swelling. We can also reduce the lifespan of the battery over time. So it might not happen immediately, but over a prolonged period of time of using the device, particularly with unofficial charges, it will increase that failure and likelihood of a fire happening. But equally, it's important to think about how we handle and how we store these batteries. The safe storage and careful handling of batteries is important, particularly if we recognise as them being damaged. And depending on the way that you have your checks and inspections undertaken, particularly with portable fines testing, are we looking at the batteries as part of that regime, or is there a reliance on the pack tester that is brought in to do that for you? We need to make sure that we've got a way of capturing damaged equipment and looking at those items. And some items, such as laptops and phones, you can't inspect the battery because it's sealed within the unit, but there are other devices where that battery can be removed, and that should really be checked so we mitigate that risk. And where we have tools that are used in harsher environments, such as some manufacturing environments or construction environments, the impact and inspection regime needs to be more thorough and more frequent. So making sure we've got proper storage, of large battery banks, proper charging stations as well. We're seeing an increase in members of the team visiting work, coming on bikes that have battery power. If those battery packs are being taken off and charged in the workplace, in the office, do we have proper charging stations? Do we have a designated area? Are those charging points in compartmentalised rooms, or are they in specially designed fire cabinets? We often see in schools they'll have cabinets for laptop charging, which they can be slid in and out. It's those sorts of considerations we need to think, and particularly where we have incompatible batteries, that might amplify the risk. So again, separation between different stored devices. And again, when it comes to that transportation and handling, proper packaging, minimise that rough handling. I do often see electrical tape holding various power tools on some sites together, and that would suggest that at the end of the day they're being thrown into a bag or they've been dropped accidentally. Whatever the case may be, that indicates there's something that's not right, and the handling of it might lead to internal damage which you can't see, and any damage to the packaging is simply an indication that there has been some sort of shock that has impacted that tool, and particularly the battery that has to be considered or concern raised. So I mentioned earlier about the kind of the physical damage and the impact from physical damage. Now we have battery fires at this 1,000-degree point quite quickly. The speed and toxicity of the output will vary depending on how quickly the thermal runaway will happen within that piece of battery within the cells. That depends on the manufacturer, the quality of the tool. But regardless of how quickly it happens, we need to think about how we minimise and we mitigate potentially any other damage that might happen within the work environment. So we know that at 1,000 degrees, lithium can burn through metal quite quickly. So therefore, having concrete or protective kind of casings where we have these battery stored areas would need to be considered. And for a lot of workplaces, that means a review of the compartmentation and the processes within the workplace. And even though fires, when they do occur, can be put out, often we need to monitor that environment because lithium fires can reignite many hours or even days after being what we call extinguished. It's a very challenging environment for the fire rescue service to say that fire has been extinguished and put out, because the power is still stored within those battery cells, and a small amount of damage over those days, weeks, can start to then reignite. And as that damage can spread around to other parts of the machine, you then end up losing the entire piece of equipment. So it's really important we think about high risk reignition, even after suppression and extinguished. What are we going to do? How are those items going to be quarantined and put into a safe place? It's not necessarily as simple as that's been put out now, it won't happen again. The items might need to be quarantined for a longer period of time. So we talked about hazards with human health, and obviously there's a little bit on just on the impact. I'm not going to spend a huge amount of time on this as we touched on it. But what we did touch on before is that because of the effects of not just the carbon monoxide, but the organic solvents and the hydrofluoric acid that's released, even a brief encounter to these toxins through inhalation can lead to long-term respiratory and neurological harm. We don't fully understand how different exposure levels will harm different people in different ways. We don't have that depth of knowledge, but we do know it happens. So again, it's really important that we think about the impact of the fire and those people attempting to extinguish that fire. And I know from the businesses that I work closely with that they have found themselves in a situation where battery fires happen, the team, those people that have been trained in a safe use of extinguishers, will continue to use extinguishers that are available to put the fire out. And they're not putting the fire out with thinking about the consequence to themselves and the harm to themselves. We know that those staff want to do everything to protect the environment, but what we've got to do is keep reminding them that they shouldn't be putting themselves at risk. They should identify the hazard, the risk to them, before there's any type of exposure that might be realised. That's a hard thing to manage. I think you have to look at the culture within your work environment, and also telling them firmly that it's okay to step away, because we don't want to have those effects, like we've seen with other exposure to things like asbestos, etc. 15, 20 years down the line, we want to make sure that it's something that has a negligible impact on risk for the rest of their lives. Obviously, with any fire, there's quite a lot of real world business kind of impact studies that have happened as a result of um, fires. But where there is this potential risk of reignition, the disruption can be far greater, because you might have the fire brigade on site for longer. The cleanup may take longer because of the hazardous content of the batteries. It's not necessarily as simple as just going on with your normal workflows. You're going to have to bring in specialist waste and cleanup teams. There's also then the impact of the investigation, trying to understand how these fires might happen. Um, I suppose one of the things we need to recognise is that where we are currently with legislation, when we talk about the overall piece of law within the Regulatory Reform Fire Safety Order, when that was written, and subsequently when we had guidance such as PAS 79, that methodology for risk assessment, that they were written and they were kind of put together at a time where lithium batteries weren't so prevalent. They were there and they existed, but they weren't as much integrated into our working lives and into society. So investigations often end up creating, there's delays, there's sometimes a lack of guidance, and as a result of that, there can be some very expensive infrastructure that needs to be installed to particularly help deal with critical elements within your work processes. And obviously, if the impact is great enough, a significant number of organisations wouldn't recover just because of the damage and the drastic impact from these lithium fires. We also know that the financial costs, the expensive repairs, loss of assets and equipment, stock and vehicles can be extremely costly. Whether that equipment is hired in, whether it's on a finance agreement, or whether you own it outright, insurance premiums typically will rise as a result after those costs. And obviously, we know that there's a difficulty there may be in meeting those kind of contractual deadlines. There also will be, in some organisations, pressure to get the ball rolling, get the business moving forwards again, because time is money, and to have too much stand down time can have a devastating effect on the organisation. So it loses out on those opportunities to kind of recover some costs. Now, with regards to the impact and the environmental impact, we're going to see all of these things brought together in a short video in a moment. But firefighting runoff often will contaminate oil, soil, and water. Um, that water runoff is down to you. The fire and rescue service will try to contain as much as they can, but it's down to you to do that environmental risk assessment, to think about how soil contamination might occur, and also think about any other chemicals you might have site that might enter the environment as a result of a fire. So we know that damaged batteries are hazardous waste. They need to be handled correctly by a hazardous waste licensed contractor and disposed of in the right methods. Disposal, though, does become a problem, maybe not within the work environment so much, but we do see it as an issue within the domestic side, where we're seeing lots of damaged batteries, or batteries that no longer work, unfortunately being disregarded and put into general waste. Then they're part of that cycle where they could catch fire within the waste bins that are collected by the local authority or your private company, or they could end up at the waste recycling centres, where consequently there is now a significant increase of fires. It's almost a daily occurrence that we're seeing. So damaged batteries need to be handled properly. They need to be dealt with and handled in a way aligned to your policy. So getting that information out to your staff will not only help to deal with the workplace risk, but it also deals with a bigger impact in society and the cost of the waste sector. Yeah. So I've got a short video. I've got lots of videos. All these videos that we've pulled into the presentation are available online on YouTube. You can find them. Some of them are via the companies. So there's a few different kind of companies. You might recognise some of them. So this first video is just going to talk about some of the different examples of lithium fires that we see through both our home and in our workplace. And it's about making sure that we understand they exist and they're being considered as part of that wider risk assessment. So you should be able to see this video, and there's also a bit of sound with this first one.
The purpose of this showreel is to provide some real-life examples of lithium battery fires and illustrate the different ways the fires present in the different devices. First, here are some examples of typical smaller device lithium battery fires which have been featured on YouTube and in the news. Mobile phone fires. A standard mobile phone comes with a built-in safety device which will usually switch it off at about 40 degrees centigrade. But if, for example, the phone was left in the sun on a car dashboard, it will continue to heat up until it catches a light. Mobile phones contain a small lithium battery, typically 60 watt-hours or less. E-cigarettes. These contain a cylindrical cell battery. There is virtually no warning. They almost seem to spontaneously ignite. This can be particularly dangerous when kept in a pocket. Power banks. These devices contain larger size cell batteries, typically 4 times 21/700s, which can charge a phone 3 or 4 times. That amount of stored energy can cause quite a significant fire if the power bank is in a bag or pocket. A lithium battery powering a laptop is usually between 60 and 100 watt-hours and is capable of spraying debris across the office, so is likely to set other areas of the room on fire too. Electric scooter fire. There is more warning with this as smoke is emitted first, but it still erupts into a fire quickly. The lithium battery is in region of 500 to 750 watt-hours. Electric scooters are now banned on TfL network due to fire risk and regular fire incidents which have taken place. E-bikes. These can have up to a kilowatt-hour lithium battery. Just like the e-scooter, the fire starts by emitting smoke first. Using a garden hose to spray the battery with water doesn't make any difference to the fire. It just keeps going. And now for some larger fires involving a recycling centre, a battery energy storage system, BESS, and a couple of electric vehicles. The recycling centre. All lithium battery devices have built-in obsolescence, so once they have been through up to 1,000 cycles of recharging the battery, will need to be replaced. It's worth noting that this is also true for electric vehicles. So the number of batteries and devices which are going through recycling centres is ever increasing. Powder extinguishers are often used on large lithium battery fires in recycling centres, but these are ineffective, so the battery will continue to reignite. 0.7 litres of smoke is generated per battery watt-hour. Therefore, a 6.5 watt-hour battery will generate at least 5 litres of smoke. Next is a video showing testing of the fire hazard of a 125 kilowatt-hour energy storage system comprised of lithium nickel oxide, lithium manganese oxide batteries. The fire smokes for a long time, but once the flames break through, the whole container is destroyed due to propagation of thermal runaway from pack to pack. In China, there was one of these container fires per month last year. Electric vehicle fires can reignite hours, days, or even weeks after being extinguished. So the key question is, when is a fire out? The fire brigade struggled to douse the fire even using 3,000 gallons of water. Fire chief, making the world a safer place.
Okay, so some really interesting bits within that video, and I spoke to an ex-fire officer recently, and he said one of the things that we probably don't consider, particularly as we have seen the growth of things like e-cigarettes and the use of power banks, is that the way the cells are usually put together, once you start to get that thermal runaway, it's almost an explosion. It's like having like a mini bomb in your pocket. Um, and whilst it's not explosive in detonation terms, and there's the physical damage from the explosion, what we often get is this smoke, and then followed by quite high temperatures. And that is a risk that we need to be mindful of, particularly around that charging, not charging things overnight, whether they're left on in the office or whether they are being charged at home. They should be charged in a supervised manner. It's almost the same guidance we had that when we used to be at home, and so when you're cooking, make sure you're supervising your cooking so you don't have fires. It's the same with charging. We should be considering those factors. And in that video, we also saw with the laptop, when it exploded, there was hot particles that were shot across the room. If that's an office environment and maybe the bins haven't been emptied, or there's a large amount of stored materials, as we still have lots of paper within the workplace, there could be that secondary fire starting quite rapidly as the first one starts to die down. So it's really important we think about the consequences, and we think about what it is that we have in the office. I think to a large extent, these lithium fire examples that we've just seen, we kind of accept that they are rare, but at the same time, when they do happen, they are significant. I would also add that that rarity isn't becoming as rare as it once was. It's starting to see an increase. So these are some statistics. There's lots of various statistics out there, but these are just a little bit that I pulled together. So what we see here is a combination between 2022 and 2024. We can see that there's essentially a doubling in essence between 2022 and 2024. E-bike fires doubled from 181 in 2022 to 326 in 2024. I don't have a breakdown of whether those bikes were from the manufacturer or where those e-bikes had been a battery pack had been added to them. E-scooters, an increase of 32%, and particularly as the cost in some of these products reduces, we see some of those there is a significant increase in risk. So from 32% of 118 to 156 in 2024. Electrical car fires increased by 77% from 2022 to 2024. That doesn't mean that you should suddenly not buy an EV vehicle if you have one. EV vehicles are extremely safe. The reason there's been an increase is because there's significantly more within society. Regarding waste systems, over 1,200 fires caused by lithium-ion batteries, most thrown in household bins over that 12-month period of 2024. That's a lot of fires. As I said, it's a daily increase. That's a 71% increase between 2022 and 2024. And we're seeing that continually grow and rise. So education of our family, our friends, those people that are in our society really is important. And we do know that the kind of inner city locations have increased prevalence. So we know that within London, the London Fire Brigade reported a significant increase in attending fires. They had 407 e-bike and e-scooter fires, so that was over one a day in 2024. And that number has quadrupled. It's actually quadrupled between 2020 and 2024. And you see it, don't you? You see more e-bikes in society. You see more e-scooters. And I know there's a question about the law around e-scooters, but the fact is the fires are happening. So that advice about how they're stored when they come into the workplace, storing them outside, making sure they're not in our corridors, and particularly in the home where they're being charged, charge them in an area where they're not going to restrict that egress. The e-scooter that we saw in the video on the previous slide, that smoke very quickly, within a matter of seconds, completely filled that room that it was in. And if you were in an environment where you are sleeping, there is a delay in you waking, then that speed of ignition might actually restrict your safe egress route. And one of the things that we do have in a lot of homes is still, unfortunately, a lot of deaths because there was a lack of automatic detection, whether that's battery operated or battery with mains power backup. So in the video towards the end, it showed that there was a fire within a waste recycling centre. And it talked about the fact that most commonly the staff will use powder extinguishers. Powder extinguishers are very good at interfering with the chemical chain reaction. And that chemical chain reaction is good at stopping the fire growth in some respects. But what it doesn't do is it doesn't interfere with that thermal runaway that's happening within the battery cell itself. So when it comes to standard fire extinguishers, dry chemical has a limitation, but also CO2. CO2 is very ineffective at dealing with this type of fire. We normally relate CO2 to electrical fires, and what that does is it disrupts that oxygen. It moves that oxygen away. But the problem with our lithium is it self-generates its own oxygen, so it doesn't need the oxygen necessarily in the air for that thermal runaway to occur. And the use of water can create quite violent reactions. At best, it will do absolutely nothing to reduce the heat and the fire, but at worst, it will make the situation far worse. And it's important, therefore, to think, well, if you do have an electrical fire, how you are going to deal with it and how you are going to challenge it. That isn't the same as dealing with a fire from lithium-ion batteries. Now, if you are to do a bit of research online, one of the things you might come across is a Class D extinguisher, which is an L2 metal powder. So metals such as titanium, magnesium, potassium will all readily burn. And these extinguishers are for metals, and that metal also includes lithium. This extinguisher is perfect for those combustible metals. Now, combustible metals on their own, once they start that process of combustion, can get as hot as 5,000 degrees and above, so extremely hot. And these extinguishers are specially designed for metal fires. They contain special dry powders such as graphite-based agents, copper powder. It smothers the fire by forming a crust to cut off the oxygen. But these aren't really suitable for anything other than the metal application. They're not the most usable extinguisher for lithium-ion batteries. We also need to be mindful if you're using a traditional powder extinguisher or a L2 metal powder extinguisher, that the guidance around extinguishers in the British Standard, which is 5306, talks about the use of powder extinguishers has to be considered with regards to the discharge, particularly within buildings, because this can cause sudden reduction of visibility. It can also impair breathing, which can temporarily jeopardise the escape route or other emergency accidents. And for this reason, powder extinguishers should generally not be specified for indoor locations unless mitigated by the health and safety risk assessment in some way, shape or form to consider that what if. So whilst these exist, they're out there, and we know that powder extinguishers do have some benefits, realistically what we want to use is a low ion, a lithium ion specific extinguisher that is able to encapsulate and reduce the temperature. So by doing that, the exothermic reaction of a lithium ion battery, we're trying to absorb some of that energy. So by encapsulating it, we will do a much better job, as we can call it down on top, and we tick 2 boxes. So we've seen this kind of ever-increasing growth within the marketplace, and this is the sort of thing that you've probably seen in different locations. So strictly speaking, Class L doesn't technically exist. industry is working together with the British standards and guidance documents that are out there. So whilst we have classes A, B, C, D, and F, class L, whilst it's not quite there, we're starting to see documentation come through, and we do expect that in next year, some manufacturers are saying it'll be the early part of next year. Other manufacturers are saying, well, we think it's going to be the latter part of next year. It's likely that there's going to be a reclassification for lithium ion batteries specifically, and that will be a class L fire. Subsequently, as part of that, manufacturers are already aware that their extinguishers, which has got an aqueous vermiculite dispersion, are perfect for putting out these fires. So these extinguishers are marketed specifically for the risk associated with battery fires. What we have to do is understand what that extinguisher does, how it operates, also what the safety concerns. Because these extinguishers are specially formulated to deal with a fast growing, rapid fire, we also need to make sure that the staff are trained to be able to use these extinguishers swiftly and effectively. So we need to think about where these extinguishers are being positioned, um, making sure that they have been designed to capture the locations where a fire may happen. We also need to think about what the effect of that extinguisher will be on the particular device. So whilst they are designed to put these fires out, a lot of fires, unfortunately, the battery is encapsulated within a piece of equipment, piece of machinery, which means access to the battery is not direct, in which case the effects and use of these extinguishers possibly will have a limited impact. So we need to think about how we can effectively suppress the fires in the early stages. We need to think about whether these devices could be put in areas where there's a physical barrier to maybe inhibit oxygen getting into the environment. We also need to think about the electrical safety of the equipment that's being used, the workplace, such as charging stations, whether they are left out on the side, and also the location of things like charging bays. All of these things have to be considered within that wider scope of use of these extinguishers. We must therefore then look at matching the correct extinguisher to the right battery type. And you will start to see this picture on the right hand side, which is the NTA test standard. This is a Dutch test standard, NTA 8133 in 2021. This was a Dutch test standard that essentially said that we need to have a solution for dealing with lithium battery fires. And this Dutch test standard has really been the first agreed standard. It's the most widely recognised standard across Europe and globally for specific hazard. And gradually it will make its way into the more common framework for British standards, European standards, and there's global kind of norms. But we need to look at what that extinguisher can do. As it says on this label, it's up to 600 watt hours. We talked in that video, or there's a demonstration in the video from Fire Chief, that the scooter would typically have a battery that's between 500 and 750 watt hours. So what we're saying is these extinguishers, if it's only 600 watt hours, will have a limited effect. You've got to understand the watt hours in the device that you're trying to put out. It's not like a traditional extinguisher in that we have direct contact and we can put out maybe a larger fire. What we see here is these fires are only effective on smaller devices. Okay. They're also quite expensive in reality. So this is the second video I'm going to show. There's no sound with this video, but what you'll see as this video is playing is the effects on how overcharging. So there's a forced charge into this battery. You'll see quite quickly a small amount of smoke, and then there'll be the thermal runaway, and then you'll see the video of the extinguisher being used. But look, this battery is exposed. This battery isn't contained within a device, and this battery also is extinguished quickly. So we've got that thermal runaway. Remember, an indoor environment, we're going to have quite a lot of smoke produced. There we have the extinguisher being used, and you can see it's starting to build up that layer. Now that layer that's been applied, that aqueous vermiculite that's been applied, that has what's called an endothermic reaction. It absorbs some of the heat, and that's what keeps the fire from reigniting. But it's also worth pointing out that that extinguisher was to hand. That stopped the fire getting too big. And also, you should note that as the fire has been extinguished, the person that's walking around, as you can see there, is wearing fire-resistant clothing. So it doesn't necessarily mean that you can't have these extinguishers available, but we have to consider the risk to those individuals that might be using them. Okay. The alternative to extinguishers are blankets. There are lots of different blankets on the market, so it's important that if you've got a blanket, is again the right size for the equipment. We need to check if the blanket is suitable. So it might be for an SUV, it might be for a larger forklift truck, or it could be for e-bikes. You need to check the suitability of that blanket. We need to make sure that it's the right blanket to be designed. So these blankets have a higher specification because they deal with higher heat levels, and there is a specification, as you can see, for compliance for higher quality fire blankets to achieve. And it's really important that if you select a fire blanket, we recognise it's not a cheaper blanket that's been bought that doesn't meet that specification. So check the manufacturer and check what's out there. I've had conversations over the last kind of 12 months about different manufacturers. I heard a story from one manufacturer, and the question was, what if the fire doesn't get put out by the blanket the first time? And their answer was, well, you just use a second blanket. But these blankets are in the region of about £1,500 for the larger ones. A second blanket is not the option you want to go for. So please do your research. So again, I've got a short video. This is for the blanket that was in the picture. This is a Bridge Hill blanket. It's being used on a vehicle test fire. And I think this is really interesting, actually, because we've got a 64 kilowatt hour battery, and obviously there is a fire that's been started. Now, it's important to recognise in this video that the condition of the car is fairly modern. There's no obvious signs of damage. They forced the fire to occur. So, for all intents and purposes, a normal car fire might break out in a slightly different way, different behaviour. But look, this blanket is being rolled out. It's being rolled out by firefighters that have got full breathing apparatus. They have fire-resistant clothing on, and they have been trained and responded to this quite quickly. Where we kind of see these blankets being used is not actually by the workers, by your fire marshals. It's likely that these blankets will be provided by the employer. They will be left outside the building or in a location that's easily accessible, such as a reception lobby. If you then had a vehicle car fire like this, when the fire brigade attends, they will put the blanket onto the vehicle. The blanket has to stay on the vehicle for 18 hours. That's what's done in this test. But what you can uniquely see here is the front end of the vehicle, because the blanket was applied quite quickly, there's still air in the tyres. There's very little damage to the front part of the car. Well, if that's what's happened in this situation, if you think about where you've got EV charging on site and you've got those vehicles close to the front of your building, it's not just that one car that will be impacted, it's potentially other cars near it. So the fire and rescue service at no point will be putting these fire blankets as we stand at the moment into their vehicles. There's not the space for them. The vehicles are designed for very specific equipment. But what we might start to see is risk assessors that you work with, through their engagement, they might start to specify that this fire blanket might be something that you should have available outside the building. It might be that insurers start to ask for it. But until such time, it's only your risk assessment that will really say that you need them. That they are there not for you to use, but for the fire brigade. Now, with these blankets, unlike a fire extinguisher, they can be quite efficient because they can usually be used anything between 15 and 30 times before you have to replace them. They immediately stop the propagation of the fire and therefore spreading. It does isolate the toxic gases, and it also drastically reduces the carcinogenic exposure to those gases that we might experience. And obviously, the cleanup is a lot greater in terms of reduction because you don't have the water runoff. And research has kind of shown that upwards of 50,000 litres of water are sometimes needed to put out EV fires. If you have poor water supply on your site or low water pressure in your area, the risk assessment with your EV charging might warrant the need for a blanket of some sorts that has been tested and approved. So when it comes to your battery powered equipment, it's all about kind of that prevention is better than cure. Make sure that you've got regular inspections in place, making sure that those regimes such as pre-use checks, the location of items being stored, the policy around bringing equipment in, all of that has happened and it continues to happen. We make sure that where staff are using charging devices, it's proper charging with certified devices that match up to the equipment. Just because something has a CE marking on it doesn't necessarily mean that it is the right bit of kit for that tool or item to be charged with. Implement workplace battery fire responses. As part of your fire management plan, there should be something in there where you've got batteries on site to decide whether your plan will suitably deal with the impact as a result of a lithium ion battery fire. And that's sometimes missing within some policies that I see, and there's a lack of training around that plan. So whether you're going to buy a lithium extinguisher or you're going to buy one of the fire blankets that we've seen, if you're going to select those, you need to provide that adequate information, instruction, training. Remember that prevention is better than cure, but what we can't do is completely remove the risk of a fire from a battery powered device because we just don't know when they will happen. So we need to have some tried and tested plans in place because otherwise these lithium batteries that we're using, which are part of modern society, will pose a serious risk. It will put our staff at risk. They may select the wrong extinguishers, and the short-term harm and the long-term harm will be more likely to be realised. Selecting the right extinguisher. Speak to your contractor that you use for fire extinguishers. Try to understand what they need. If you've got any other kind of questions, then look and do that research. But what I would certainly say is don't just say that because you've got lithium-ion batteries in your building, an extinguisher that is available is the right solution because they are expensive. They might increase the risk significantly, and actually removing those batteries from the risk assessment and the procurement process might be a better option. So that brings me to the end of my webinar today. Hopefully Rob will jump back online. I'm assuming there's a few questions, so we've got a little bit of time. Any questions we can't answer, we'll go back and deal with. So over to you, Rob.
Indeed. Thank you very much again, Phil. Yes, very quite comprehensive. We've had a couple of questions come in for yourself.
Okay, I'll do my best.
The first one we had there. Have there been any EA prosecutions linked into firefighting runoff?
There will be prosecutions from firefighting runoff from the Environment Agency. The Fire Rescue Service have a dispensation where they can't be prosecuted, and it is the responsibility of the workplace to ensure that it has measures in place, whether that be clay matting to put over drains, whether that is bunding within car parks. That will be that environmental impact. Off the top of my head, I wouldn't be able to quote any recent cases, but they certainly will have happened. But the Environment Agency is more likely to target high-risk environments before the fire happens if they've got concerns. But they will be out there, and certainly if you want to find a bit more, a quick bit of look online or otherwise, I don't mind having a look and finding some bits and coming back.
Also, we've got another question coming through where there is a bit worried about firefighting on L fires. If DCP and cooling systems aren't effective, what then is?
What then is?
Yeah,
It's a good question. I suppose in the question we're looking for a an answer in we have a fire, what will extinguish that fire? From a risk perspective, I suppose these extinguishers that are there for some organisations that are very risk averse, they're kind of a comfort blanket to say at the early stages of a fire they will put them out. And there's this tried and tested method that we've seen with the Dutch test standard. But the reality is the only thing that I can see out of everything I've shown you today is those fire blankets. But those fire blankets aren't to be used by untrained people unless you've got fire resistant clothing on and fire and breathing apparatus. That said, when you approach these sorts of fires, it's really important that we get that early knockdown. So whilst we try to risk assess and prevent the fire from happening in the first place, if it's a small fire, those extinguishers will possibly have a positive. They are going to have a positive effect, but the extent of it we don't know, depending on how the battery's been encapsulated within the design of the tool or the equipment. But if we can recognise the fire quickly and we can respond to it quickly, the chances that fire will grow substantially will be reduced. But the reality is, what we're seeing from the fire and rescue service is that they're looking for containment. They're looking at how those fires occur, how you separate it from the rest of the combustible materials in the building, as well as having that focus on the evacuation. So, in answer to the question, there isn't an answer that is this is the suitable solution, but you have to look at isolating that fire, having better containment, and having a quick response. The primary part of that response is raise the alarm and get everybody out. So it might not quite answer the question. I do apologise if it hasn't.
we've got a last one here. How likely is it that firefighters would really be willing to use firefighting equipment over which they've had no management or control, thinking of the fire blankets?
So with regards to that these fire blankets, in all fairness, what's happening is the manufacturers of these blankets have recognised the risk, and therefore they've manufactured a blanket that works. It's tried, it's tested, it's proven. It's down to the industry to approach the fire and rescue service and lobby government to say, look, this is the way forward. They've already had feedback from the chief fire officers within the UK to say, we don't have the space on our vehicles, and also we don't have the budget to put a £1,500 fire blanket on every vehicle. Because if you put it onto a vehicle, we attend the fire, the next fire we go to is not there. So the way the industry is seeing it is that we will have these blankets considered as a part of a risk assessment or driven by insurers. So in the future, it will be you should have, because you have e-vehicles at the front of your building being charged or in your car park, you should have a fire blanket there, like you have fire extinguishers. But they will be, the fire service will then likely have training as we move forward into the future. But like with any fire risk assessment now, having that fire information pack for the fire and rescue service will be to provide them with that to say, look, we have a fire blanket that's tried and tested for vehicles. So even though they've not had specific training as yet, it's going to happen. It'll be a matter of time. But providing them with that blanket, they will use it. If they see it there, they will use it. That knowledge is already going out. And in fact, through Nottingham Fire and Rescue Service, I had one of the enforcement officers on the course recently. So I know they're really keen to understand how this equipment works, and they're going to start to do some more research and some kind of training with it. And that's gradually what I think will cascade throughout the rest of the country. It's not an exact solution though, but without the training, will they use it? Probably. You just got to make it available. But consider your overall risk. If the risk of a fire at the front of your building is where your EVs are, the risk of loss to the rest of your building could be significant. I'd be tempted to spend £1,500 on the blanket to say it's there just in case. Okay. Any other questions?
No, that's it. We've come to the end, and thank you very much for that, Phil, and thank you everybody else for attending and staying through to the end. And hopefully keep an eye out for the next presentation. And again, thank you very much, Phil.
Thank you, everyone. Have a good afternoon.